Hi, engineers. Under interview pressure, can you move all zeros to the end without breaking order on your first try? In this video, I'll show you how. So today, let's solve one of the most popular interview problems, move zeros. Here's the problem. Given an array of numbers, move every zero to the end while keeping the original order of all non-zero numbers. Ideally, do it in place. Let's rephrase it in plain English. We scan a list of numbers. Every time we see a real value, we keep it in front. And every time we see a zero, we make sure it ends up at the back. The relative order of the non-zero values must stay the same. No shuffling allowed among the real values. First, let's set up 3 example inputs so we can test them later. We create a variable named A1 as the list of 0, 1, 0, 3, 12. Then we create a variable named A2 as the list of 4, 5, 6. And we create a variable named A3 as the list of 0, 0, 2, 0, 1. How do we solve it the beginner way? We will build a new list. The idea is very simple. One pass to collect all non-zeros. Count how many zeros we skipped, then append that many zeros to the end of the new list. This keeps order automatically and is easy to reason about. In some interviews, they ask for in-place only. We'll do that as our advanced version next. Here's the code for the first solution. Let's create a function named moveZeros that takes one input named nums. We will return a new list. Inside the function, first, we declare a variable result and set it to an empty list. After that, we declare a variable zeroCount and set it to 0. We'll use it to remember how many zeros we've seen. Next, we create a for loop. We declare a variable I starting at 0. We keep going while I is less than num's length, and after each round we increase I by 1. Inside the loop, we declare a variable x and set x to nums at I. Then we create an if statement. If x is strictly not equal to 0, we push x into result. Otherwise, we increase zeroCount by 1. Now we create another for loop. We declare a variable k starting at 0. We keep going while k is less than zeroCount, and after each round we increase k by 1. Inside this loop, we push the number 0 into result. This loop runs exactly once for every 0 we counted earlier, so we append the correct number of zeros at the end without changing the order of the non-zero values. When this loop finishes, all zeros are appended and the list is ready to return. Why this works? We preserved all non-zero values in the order we saw them. Then we added the correct number of zeros at the end. It's clear, stable, and beginner-friendly. The trade-off is that we used extra space for the new list. Now, let's test this solution with our variables. We write a console log of moveZeros of A1, then a console log of moveZeros of A2, and finally, a console log of moveZeros of A3. When we run the file in the terminal, the expected results should be, for the first one, 1, 3, 12, 0, 0. For the second one, 4, 5, 6. And for the third one, 2, 1, 0, 0, 0. All right. Now let's create the more advanced and interview-preferred approach in place. We will keep the order of non-zeros and write them forward as we scan. The key idea is a right pointer. Quick idea in simple words. We declare a pointer named W that marks the next slot where a non-zero value should go. We scan the array left to right with I. If nums at I is non-zero, we copy it into nums at W and we increase W. After one pass, every non-zero has been written into the front segment 0, W. Then we fill the rest of the array from W to the end with zeros. This is stable. The first non-zero we meet is written first, the second is written second, and so on. Here's the code for the in-place solution. We create a function named moveZeros in place that takes one input named nums. Inside the function, first, we declare a variable w and set it to 0. W means next right position for a non-zero. Next, we start a for loop. We declare I starting at 0. We keep going while I is less than num's length, and after each round we increase I by 1. Inside this loop, we create an if statement. If nums at I is strictly not equal to 0, we set nums at w to nums at I, and then we increase w by 1. This finishes the first pass. Every non-zero is now compacted at the front in order. After that, we create a while loop to fill the tail with zeros. The condition is w is less than num's length. Inside the loop, we set nums at w to 0, and we increase w by 1. Finally, we return nums so it's easy to print during tests. Why this works? We used one forward pass to keep all meaningful values in order and one quick fill to add zeros at the end. No swaps are needed, and we never break the relative order. This meets the usual interview requirement, O of in time and O of one extra space. Now, let's test the in-place solution with the same variables. We write a console log of move zeros in place of A1, then a console log of move zeros in place of A2, and a console log of move zeros in place of A3. When we run it, the expected outputs are the same as before. For the first one, 1, 3, 12, 0, 0. For the second one, 4, 5, 6. And for the third one, 2, 1, 0, 0, 0. Tiny complexity recap. The beginner version runs in linear time and uses extra space proportional to the array size. The in-place version runs in linear time and uses constant extra space. Common mistakes to avoid. Don't use the double equals with strings and numbers mixed. Use strict checks. Don't reorder non-zeros by swapping freely. That can shuffle their order. Don't forget to fill the tail with zeros. Otherwise, leftover values remain. That's it. We learned 2 ways to move zeros: a beginner approach that is clear and the in-place pointer approach that is interview-ready. If you can explain the pointer idea in your own words and write the 2-pass code smoothly, you are ready for this question in a live coding session. Now you're 1% smarter. The cheat code is consistency, so keep boosting your brain. Make it your daily routine, and you will nail your next interview. Same rhythm tomorrow at Code Crack Interviews.